Glass. It's in our homes, our cars, our phones. We interact with it every day, often without even realizing it. From the moment we wake up and check our smartphones to the windows we look through and the cars we drive, glass is an integral part of our daily lives. It's a material we often take for granted, but the story of glass is a fascinating one. It's a tale that spans centuries, cultures, and continents. From the ancient artisans who first discovered how to shape it, to the modern engineers who push its boundaries, glass has always been a symbol of human innovation. It's a story of science, engineering, and human ingenuity. The molecular structure of glass is unique, allowing it to be both strong and flexible. Engineers and scientists have spent years studying its properties to harness its full potential. Glass is an ancient material. People have been making glass for thousands of years. The earliest known glass artifacts date back to around 3500 BC in Mesopotamia. These early pieces were often small and decorative, showcasing the skill and creativity of ancient craftsmen. The earliest glass objects were likely beads. These beads were not just decorative, they were also used as currency and in trade, highlighting the value placed on glass even in ancient times. Over time, we learned to shape and mold glass into incredible forms. The invention of glass blowing around the 1st century BC revolutionized the production of glass, making it more accessible and versatile. Today, glass is more than just windows and bottles. It's used in architecture to create stunning buildings, in art to craft beautiful sculptures, and in technology to develop innovative products. It's a high-tech material with amazing properties. Modern glass can be engineered to be stronger, lighter, and more durable than ever before. It can be made to be transparent, translucent, or even opaque, depending on its intended use. We use it in everything from fiber optic cables to spacecraft windows. Its ability to transmit light and withstand extreme conditions makes it invaluable in many advanced technologies. Join me as we explore the world of glass, ceramics, and binding materials. Together, we'll uncover the secrets behind these incredible substances and learn how they shape our world. Glass is made from simple ingredients. The main ingredient is silica, which is found in sand. Other ingredients, like soda ash and lime, are added to change the properties of the glass. The composition of glass determines its properties. For example, adding lead oxide makes glass sparkle. This type of glass is often used for crystal glassware. Changing the composition of glass also changes its melting point, durability, and clarity. Scientists can fine-tune the properties of glass by carefully controlling its ingredients. This ability to tailor glass properties makes it such a versatile material. There are many different types of glass, each with unique properties and uses. Soda lime glass is the most common type. It's used for windows, bottles, and jars. Borosilicate glass is heat-resistant and used for cookware and lab equipment. Lead crystal glass is known for its brilliance and clarity. It's used for fine glassware and decorative objects. Fiber optic glass is used to transmit data at high speeds. It's essential for telecommunications and the internet. These are just a few examples of the many types of glass and their applications. Glass is an amorphous solid, which means it lacks the long-range order that is characteristic of crystalline materials. Unlike crystals, where atoms are arranged in a highly ordered, repeating pattern, the atoms in glass are distributed more randomly. This lack of order is what gives glass its unique properties and makes it distinct from other solid materials. In a crystal, the atoms are arranged in a precise, repeating pattern that extends throughout the material. This regular arrangement is what gives crystals their characteristic shapes and properties. However, in glass, the atoms are arranged in a more disordered manner, which means there is no repeating pattern. This random arrangement of atoms is what defines the amorphous nature of glass. The random atomic structure of glass results in a material that is both unique and versatile. This disordered arrangement allows glass to be formed into a variety of shapes and sizes, making it an incredibly useful material in many different applications. From windows and bottles to fiber optics and smartphone screens, glass plays a crucial role in our everyday lives. One of the most well-known properties of glass is its transparency. The random arrangement of atoms in glass allows light to pass through it with minimal scattering, which is why we can see through glass so clearly. This property makes glass an essential material for windows, eyeglasses, and many other applications where transparency is important. In addition to its transparency, the amorphous structure of glass also contributes to its brittleness. When glass is subjected to stress, it tends to break in a more random manner, rather than along specific planes like a crystal. This is because the lack of a regular atomic structure means there are no defined planes of weakness in the material. The brittleness of glass is a double-edged sword. On one hand, it allows glass to be easily shaped and molded into a variety of forms. On the other hand, it means that glass can shatter easily when subjected to impact or stress. This is why safety measures such as tempered glass and laminated glass are often used to enhance the durability and safety of glass products. When glass breaks, it doesn't cleave along specific planes like a crystal. Instead, it fractures in a more random way, creating a variety of shard shapes and sizes. This random fracturing is a direct result of the amorphous structure of glass, which lacks the regular atomic arrangement found in crystalline materials. Understanding the structure of glass is key to understanding its properties and how it behaves. By studying the atomic arrangement of glass, scientists and engineers can develop new types of glass with enhanced properties, such as increased strength, improved transparency, and greater resistance to thermal and mechanical stress. The study of glass structure is not only important for developing new materials, but also for improving existing ones. By gaining a deeper understanding of how the atomic arrangement of glass affects its properties, we can continue to innovate and create new applications for this versatile material. From everyday objects to advanced technologies, glass remains an essential and fascinating material in our world. Section 5. The strength of bonds in glass. The strength of the bonds between atoms in glass determines its properties. Strong bonds make glass hard and durable. Weaker bonds make glass more flexible. For example, silica glass has very strong bonds. This makes it very hard and resistant to heat. However, it also makes silica glass brittle. Adding other ingredients to glass can change the strength of the bonds. This allows scientists to engineer glass with specific properties. The study of bonds in glass is crucial for developing new and improved glass materials. Section 6. Advanced glass technology. Scientists are constantly developing new and innovative types of glass. These advanced glasses have unique properties and applications. Gorilla Glass is a type of chemically strengthened glass used for smartphone screens. It's incredibly tough and resistant to scratches and cracks. Self-healing glass can repair itself from minor scratches. This technology has the potential to revolutionize the way we use glass. Bioactive glass can interact with living tissue. It's being used in medical implants and bone regeneration. These advanced glasses are pushing the boundaries of what's possible with this versatile material. Section 7. Glass in industry. Glass plays a vital role in many industries. It's used in construction, transportation, electronics, and more. In construction, glass is used for windows, doors, and facades. It provides natural light, insulation, and aesthetic appeal. In transportation, glass is used for windshields, windows, and mirrors. Safety glass, like laminated glass, is essential for protecting passengers in case of an accident. In electronics, glass is used for smartphone screens, television displays, and solar panels. The applications of glass in industry are vast and constantly evolving. Section 8. Ceramics and binding materials. A quick look. While glass often takes center stage in discussions about materials, ceramics and binding materials are the unsung heroes that play crucial roles in shaping our world. These materials are integral to both ancient and modern construction, art, and technology. Without them, many of the structures and objects we take for granted would not exist. Ceramics, ranging from the sturdy bricks that form the backbone of our buildings to the delicate porcelain that graces our dining tables, share a fascinating reliance on heat transformation. Unlike glass, ceramics boast crystalline structures, which give them unique properties. These materials are not just functional but also hold cultural and historical significance, having been used for thousands of years in various forms. The crystalline structure of ceramics grants them impressive strength and heat resistance. This makes them ideal for high-stress applications such as engine components and heat shields. In the automotive and aerospace industries, ceramics are indispensable for their ability to withstand extreme temperatures and mechanical stress. Their durability and resilience make them a preferred choice for engineers and designers. Binding materials, including cement and adhesives, act as the glue that holds our built environment together. These materials are essential in construction, ensuring that buildings and structures are stable and durable. Cement, for instance, is a fundamental component in concrete, which is used in everything from sidewalks to skyscrapers. Adhesives, on the other hand, are used in a variety of applications, from construction to manufacturing, providing strong bonds that hold materials together. These binding materials rely on complex chemical reactions to set and harden, creating strong bonds between other materials. The process of cement hardening, for example, involves a series of chemical reactions that transform the mixture into a solid, rock-like substance. Similarly, adhesives undergo chemical changes that allow them to bond surfaces together securely. Understanding these chemical processes is crucial for improving the performance and durability of these materials. From the concrete in our towering skyscrapers to the glue that holds together the pages of a book, binding materials are essential for both construction and manufacturing. They provide the necessary strength and stability for large-scale structures and the precision and reliability needed in smaller, intricate applications. Whether it's building a massive bridge or assembling a delicate piece of furniture, these materials are indispensable in our daily lives. Section 9. Keep exploring. The world of glass, ceramics, and binding materials is vast and fascinating. From the ancient art of glass blowing to the cutting edge of material science, these materials have shaped our world and continue to push the boundaries of what's possible. I encourage you to keep learning and exploring, delve deeper into the science behind these materials, discover their countless applications, and imagine the future they will help us build.